So in this video, we'll discuss about the topic of first derivative test from the differential calculus 1. We are going to see how to get what we need to make a graph in different steps. Step number 1 is to get the first derivative from an equation. We have f of x equals negative 2x cubed plus 4x squared plus 6. We find the first derivative by making the following process, and we'll get by answer negative 6x squared plus 8x.
After finding the first derivative, we need to solve for x in order to get the critical values. In this specific problem, the critical values were 0 and 4/3. The critical values are the values of x, where first derivative of x is undefined.
Step 3. Mark the critical values of the number line. For this, you have to understand the intervals, which are negative infinite to 0, 0 to 4/3, and from 4/3 to positive infinite.
Okay, so now we need to fill in the table. The first thing we need to do is to write the intervals of the function, which were mentioned previously, and they are negative infinity to 0, then 0 to 4/3, and from 4/3 to positive infinite. Then we need to choose an x value that is inside the interval. In this case, we chose negative 1, 1, and 2. Now we need to replace it on the first derivative, which is minus 6x squared plus 8x. We substitute the x by the x value, and in the second column we'll get minus 14, then 2, and then minus 8. And then we just need to know the sign of the results we got previously, which can be negative or positive, and this negative or positive sign will indicate us if the graph is increasing or decreasing. If it's negative, the graph is decreasing, but if it's positive, it is increasing.
After filling the table with the intervals where the values are increasing or decreasing, we need to obtain the x values for the maximum or minimum point, often called extreme values. To get these points, one has to substitute the x with the critical values in the original equation. In this problem, we got one minimum point being 0,6 and one maximum point being 4/3, 8.37.
Tip. An easy form to get the y-intercept is to substitute the x to 0 in the function, and if you notice, the y-intercept is the same as the minimum point of the function.
So now the last step is to graph the function with the information you previously got. We got the minimum point and the maximum point, and we need to draw those points on the graph, which will be 0,6 and 4/3, 8.37. A useful tip before we graph is to analyze the original function, which is minus 2x to the cube plus 4x squared plus 6. We need to look at the minus 2x to the cube because the minus sign indicates that the graph will be decreasing, and the degree 3 indicates the form of the graph. So now we draw a line that is decreasing from minus infinite to 0, and then the line will go up to from 0,1.33, and then it will go down again from 1.33 to positive infinite. And this is the final form of the graph. We hope you understood everything, and thank you for listening to us.